Basically, we were given an assignment in class to create a product that we could sell to the people of India. And when we were researching what we should do for this project, plenty of pictures like the one you see up on the screen came onto our Google News image feed. And so we decided that it would be awesome to target this issue of unclean water and cleaning clothes because it targets so many issues that Indians face. For instance, the unclean water, the lack of electricity, different things. This would all be solved by making a portable washing machine. So that's why we chose to do this product for our project.
Before we start talking about our project, we did some research on the market and on India. And first of all, let's start with the census. We made a summary table of the population of India, and as we can see in the table, 69% of the total population live in rural communities. Therefore, we have targeted our product to be towards people who don't have electricity and need washer machines to wash their clothes, and they usually would wash them in rivers or unsanitary places. This led us to do some more research on the problem of sanitation in India, and we looked at 3 articles, and all of them proved to us that there's a serious concern with sanitation, with water cleanliness, and this is why our product fits these market. Considering our product, our rolling washer machine, which is portable, we first looked at the other competitors in India, and most of these competitors do fix washer machines like normal conventional washer machines. They're not portable, and the main competitor in India, as we can see, is LG, followed by Whirlpool, Bosch, Samsung, IFB, Godrej, Electrolux, and Panasonic. The cheapest one of these is Godrej, which is a local company, and the price for a washer machine is about 10,000 rupees. Therefore, our initial price projection, we want to sell the portable washer machine at $57, which is 3,498.94 of rupees. And we believe this is almost a third of the cheapest conventional washing machine. And also, we decided to do our demand based on that we're projecting to reach 2% of the total rural population in 2 to 3 years, and therefore we have established a demand of 125,000 products, and we're going to meet this with 4 factories along the Indian territory. Therefore, our individual demand per factory would be 125,000 divided by 4.
Well, basically what we did to refine our forecast was I found data that represents the rural population of India over the past several years. What we first did was we graphed the data. So this just shows the direction that the population is heading. And we just wanted to make sure that this population wasn't decreasing because we're targeting the rural population with our product, and if this was slowly decreasing and there wasn't going to be a population to target, then there would be no point in making this product. So we used 2 different kinds of forecasting. We used linear regression and exponential smoothing. On the next slide, we used the program R to create a formula where we can plug in the year and we would receive our predicted or estimated forecast for the different years. So we just made a quick chart that shows the predicted population from 2013 to 2012. So as you can see, the population is definitely increasing. So the target population that we're going to be targeting for our product is definitely growing, and there's a lot of room for growth for our product.
Okay, so after we did some market research and market analysis, we had to start thinking about our QFD and how we're going to design our product and what the customer's needs and wants are and how we're going to integrate that into manufacturing and start thinking about later on in the DFM what our machines are that we're going to use to manufacture the product. So for the customer's needs, for our portable washing machine, especially in the rural communities, they need clean water. So we thought that a filter is needed on our portable washing machine. And the customer's wants are that it will have clean water, it will be small, and that you can pour the water into the filter, and it will filter it through so they can roll the washing machine along. And it needs to be portable so they can use it anywhere. And ergonomics, it needs to be minimal effort to push it along, and cheap to maintain. Analyzing the customer's wants and needs to the individual components of the washing machine is integral in this process of designing how we're going to design the portable washing machine. As you can see from the chart, the water filter has a very strong relationship in weight to the need of having clean garments and pouring the dirty water through the filter. Each component of the washing machine is related by weights according to where, why, how, and when the customer is going to use the product. Design for manufacturing is a process that is used to identify which parts and which machines are going to be used within the process and in the facility, and how to maximize efficiency in production. We're going to minimize small parts. We're going to eliminate screws and bolts. We're going to fuse together the sides of the barrel with the ultrasonic welding machine that is going to eliminate the screws. We're going to use minimal variety of materials and machines. Most of our parts, a lot of our parts are made of plastic. We have the barrel, the soap dispenser, the water container, and the plug that are all made of plastic. The assembly process should maximize product efficiency. That is pretty standard. The main automation should be considered to lower tax times and increase product quality. Our company, starting off, we're pretty young, so we could consider automation for, say, like the bearings going into the side of, between the handle and the wheel. However, we are just going to use a lot of manual operations to start off with. The design and placement of the machines should be oriented to satisfy demands, tap times, and our task times that we're going to set.
For our economic analysis, we're going to compare two different processes. One process that we could possibly go with would be the assembly line process. This would simply be where the workstations would kind of be in a line and we could mass produce. We could keep sending more and more products down the line. Our second alternative would be to have a job shop production where the workstations would be more farther apart. We would have to have material handlers take the parts to different workstations once they're completed. So we would have kind of different sections of the plant doing different things rather than having a mass assembly. So we wanted to take these two and do an economic analysis to see which would yield a better profit. So first we'll look at our assembly line manufacturing. We have 5 workstations, and so we would need less workers if we had an assembly line. This shows how many we would need for each workstation. For instance, for workstation 1 we need 2 workers, and they would make $15 an hour since they're going to be working a machine. And then we can go down the line and see how many workers we need for each workstation and how much they would make. So then what we would need to do is find out the total cost of our labor. So we would have, once we added them all up, we would be paying our workers $191 an hour. Since we have a cycle time of 1.75 minutes and we can make 5 barrels in one batch, it's going to cost us $1.12 for each part for our direct labor. And on the next slide, this is our material cost. This is how much it costs for plastic, the tires, the frame, the filter, the bearings. And if you add that all up, it's going to be $19.43 for each part for our materials. So our direct cost is going to be our labor plus our materials, so our total direct cost is going to be $20.55. Our overhead cost for assembling for the assembly line is going to be 110%. So we're going to times that by our direct cost, add it to our direct cost, and our total cost is going to be $42.61. We're selling this, since we already know our price, we're going to look to solve for our profits. So we know it's going to be $57 for our price, divide that by how much it's going to cost to make it, and we get 1.34. We subtract that by 1, and we're going to have a 34% profit if we use this method. Now, for the job shop manufacturing, we're going to have a lot more employees working. Although they're going to make less, we're still going to have a lot more employees. So if you add this up doing the same thing, we find out that our labor cost is going to be $1.75 per part. Moving on to our next slide. Our material costs are going to be the exact same. That's not going to change, so we can skip over that. We're actually going to have a greater overhead cost. In this, for the job shop, it's going to be 125%. Since things are going to be more spread out, we're going to have to pay for a larger plant. There's going to be other things that go into making this have a larger overhead cost. When we multiply our direct cost times our overhead cost, we're going to end up with a total cost of $47.66 to make this. We're going to do the same thing where we divide our price by that, and we find out that we can make a 20% profit. So obviously we're going to make a much larger profit if we have an assembly line set up. So that's what we're going to do for making our washing machines.